we're going to take some notes on inverses. So an inverse function will undo a function. So the inverse of addition is subtraction, the inverse of multiplication is division, the inverse of squaring something is taking the square root. It's how you undo something. So problem 9-126 says for some function g of x, and it lists the steps. Step 1 is multiply by 5. Step 2 is subtract 8. And then step 3 is divide by 2. And it's written this way in your book, in words. So we need to write the function g of x in symbols. So g of x, multiply by 5. So you take x, you multiply it by 5. You subtract 8 from that, and then whatever you have, you divide by 2. So 5x minus 8, all divided by 2. So this goes back to Math 1 and kind of our idea of the function machine. So think about, let's take 4, for example. If we put a 4 into our machine, this is 5 times 4 minus 8 divided by 2. So 20 minus 8 divided by 2, we get 12 divided by 2, and we get 6. So if we plug 4 into our machine, a 6 is going to come out. The idea with an inverse, so you have to start from the bottom. The steps kind of, they do the opposite and in the reverse order. So it's like we're going to take a 6, put it into our machine from the bottom, and we should get a 4 out if we write our inverse correctly. The notation for our inverse here is g with a little -1 to the power of x. That doesn't mean a power of -1. That's just the notation for inverse. So step 1 here, sorry, I wrote it on the wrong line. Step 1 here is instead of dividing by 2, we're going to multiply by 2. Step 2, instead of subtracting 8, we're going to add 8. And then step 3, instead of multiplying by 5, we're going to divide by 5. So the inverse of g is 2x plus 8, all divided by 5. So again, the idea with this function machine undoing the function, if we put a 6 into the inverse, so the inverse of 6 is 2 times 6 plus 8, all divided by 5. So 12 plus 8 divided by 5 is 20 divided by 5, which is 4. And that's what we wanted to get. Again, when a 4 went in, a 6 came out. So for the inverse, if a 6 goes in, a 4 is what has to come out. And then, let's see. So problem 129 is kind of skipping around. It gives you a table. -3, -2, -1, 0, 1, 2, 3. -7, -5, -3, -1, 1, 3, and 5. So again, these numbers come straight from the book. I'm only doing part of the problem. So what inverses do is they switch x and y. And so f of x essentially is really the same thing as y. So our inverse here just takes the x columns, and now that's the y column. And the y column is now the x column. -7, -5, -3, and so on. So any point for your inverse, it switches. Like here, this was 4, 6. This is 6, 4. So your x's and y's just switch. And then 9-130. So same idea. Probably should have just done this one, but that's okay. It tells you that the function is f of x equals x squared. So -3, -1. Typically our tables go from -3 to +3. Squaring -3 we get 9, squaring -2 we get 4. Remember, when you square it, the negatives cancel out. If you do it on your calculator, make sure you put parentheses or it's going to give you negatives here. So for our inverse, I didn't quite leave enough room. That's okay. So for our inverse, these flip. So I'm going to graph it here. I'll move the paper back in a minute for you to see the rest. And it won't all fit, but that's okay. So my function, 0, 0, so that's my function, and then my inverse also goes through 0, 0. It goes through 1, -1, and 1, 1. It goes through 4, -2, and 4, +2. So my inverse looks like this here. But I want to point out, this inverse is not a function. If you remember from Math 1, to be a function, every input has to have a unique output. And so here, if x is 1, we get -1 and +1. If x is 4, we get -2 and +2, and every value in between. So this isn't a function. The inverse is actually, so undoing a squaring is the square root. But this is if the domain is x is greater than or equal to 0 for f of x. So what that means is we really only want to look at half of our parabola and half of our sideways parabola. So the square root of x, that's just this guy right here. And so to get that half, we just want this half of the original parabola, which is really, so I said for f of x is greater than or equal to 0, we're just looking at these values, which then corresponds to those values. This is kind of a tricky one. I just want to point out that not every function, the inverse isn't necessarily a function. Let's do a few examples of kind of writing the steps out again. Okay, so let's see. Let's say q of x is equal to 2 parentheses x minus 3. So our steps here, the way the steps work, it's basically if you took a number, for example, 10, and plugged it in and you didn't have a calculator, what would you do? Your order of operations. So the first thing you would do is subtract 3. And whatever you got from there, you would multiply by 2. So for our inverse, let's go with this one. The first thing we want to do is divide by 2, and then we want to add 3. So that tells us the inverse of q. So again, you always start with x. You take your first step and you do that operation. So we divide that by 2. Then we take what we have and we add 3. So x divided by 2 plus 3. Notice the fraction bar is not under the plus 3. It's x divided by 2, and then you add 3 to that. All right, we'll do another one here. Let's say j of x is equal to x minus 7 divided by 10. So again, if I told you x was some number and you were to plug it in, you would subtract 7, and then you would divide by 10. So for your inverse, you're going to, multiply by 10. Again, start from the bottom, and then you're going to add 7. So the inverse of j is, again, start with x, multiply it by 10, and then add 7. For some of these two-step equations, you won't have to write the steps out, but if this is a test when we're in class, I'm going to kind of ask you to show your work this way. And then I'm going to do one that has a few more steps. So let's say f of x, let me zoom in a little bit here. F of x is equal to 5 parentheses x plus 2, that whole thing divided by 7, and then a minus 1 outside. So if I knew x was some number, I would plug it in, I would add 2. Whatever I got there, I would then multiply by 5. Whatever I got there, I would then divide by 7. And then whatever I got there, I would subtract 1. So for my inverse, the first thing I'm going to do is add 1. Then I'm going to multiply by 7. Then I'm going to divide by 5. And finally subtract 2. So the inverse of f of x is equal to x plus 1. Then I take that and multiply it by 7. I take that whole thing and divide by 5. I take that whole thing and subtract 2. And remember to check to see if you did an inverse correctly. That kind of brings us back to that first example. You can plug in a number. So let's just say, for example, if I find f of 5, that means I'd plug in 5. And I would just follow my order of operations to simplify this. So 5 times 7 divided by 7 minus 1, which would be 35 divided by 7 minus 1. So 5 minus 1, and I'd get 4. So when I plug 4 into my inverse, I better get 5 out. If I don't get 5 out, then I made a mistake somewhere. So the inverse of 4 is 7 times 4 plus 1, all divided by 5, minus 2. So 7 times 5 divided by 5 minus 2 is 35 divided by 5 minus 2. So 7 minus 2 is equal to 5. And it worked. So again, to check if an inverse is correct, you can plug in a number. Whatever you get for the output, you plug that output into the inverse and hope you get your original number back out. And then to find your equation, list your steps and then undo each step in the opposite order.